pattern 17x31, and it goes on. So it is a quadratic number pattern. Find the value of x. So this is how we do it. Okay, you write your pattern over there, 17x31. You find the difference, 7 minus 1. Okay, this is how we always find the difference, this term minus that one. So it's something like this. Okay, so this is t1, right? This is t2, this is t3, t4. So it's t2 minus t1, which gives us this difference, t3 minus t2, which gives us x minus 7, t4 minus t3, which gives us 31 minus x. Then we continue to find the second constant difference. Okay, x minus 13, 38 minus 2x. Okay, so listen here. I know that this don't look the same, but listen. Since this is a quadratic number pattern, these two are equal because it's constant second difference. The position that they're at is where our constant difference is. So we know that our constant difference, our constant second difference is equal, right? So don't mind that this is not equal to that. We know that our constant second difference is equal. Okay, so this will be equal to that because of that reason. So we're gonna write x minus 13 is equal to 38 minus 2x. Therefore 3x is equal to 51, x is equal to 71, and you're done. Okay, just remember that. Make sure you remember that. Moving on, we have minimum and maximum terms. Okay, so consider the quadratic number pattern 399, 360, 323, 288, 255, and so on and so on. Determine the formula for the general term. Okay, so we do our thing. T1, T2, T3, T4, T5. So T2 minus T1 gives you negative 39. T3 minus T2 gives you negative 37. T4 minus T3 gives you negative 35. T8 minus it's T5 minus T4 gives you negative 33. Then you go on and find the differences between these first differences, and then that's this one minus that one gives you 2, this one minus that one gives you 2, this one minus that one gives you 2. So now remember from the previous video, a plus b plus c, you do this. Okay, so a plus b plus c is equal to that, 3a plus b is equal to that, 2a is equal to that. Okay, so now we have 3a here, as we have 3a plus b. In fact, let me begin with the obvious one, the easiest one, which is this one here. 2a is equal to 2, right? Therefore a is equal to 1 because we divide both sides here by 2, which gives us 1. Then we're gonna sub that a into this equation. 3a plus b is equal to negative 39, which is 3 times 1 plus b, which is equal to negative 39. Therefore b is equal to negative 42. We move on. A plus b plus c is equal to 399. So we're gonna substitute b and a into a plus b plus c, which gives us 1 minus 42 plus c, which is equal to 399. Therefore c is equal to 140. So b says, okay, wait, therefore tn is equal to n squared minus 42n plus 440. Okay, n squared because here a is 1, then 42n because b is negative 42, so minus 42n, then plus 440 because c here is 440. Remember the general term for a quadratic number pattern. So that's what I did here, that's what we do there. And then b, moving on, which term of the pattern will have the lowest value? Okay, this is like completing the square. This is what you should know, with completing the square, something like that. So in completing the square, people, I'm gonna tell you now. Maybe you have not heard this or you've missed this. Someone there might have missed this. So I need you to look at this. So in completing the square, if you have something like this, right, which means they've completed the square, you've completed the square, I want you to look at the value of a. If the value of a is positive, then we have a minimum value. Then if the value of a is negative, if that's the negative here, then you have a maximum value. You can even prove that by drawing the graph, the parabolic graph. You will see what I'm talking about. So remember, when it's positive, when a is positive like so, we have a minimum value, x value, minimum x value. And then when A is negative, we have a maximum x value. Okay, moving on. Which term of the pattern will have the lowest value? Okay, so Tn is equal to n squared minus 42n plus 440, right? You complete the square. Remember, I did a video about completing the square, which is why I skipped this step. So n minus 21 squared minus 1, right? So here they're saying which term of the pattern will have the lowest value. So for minimum, okay, for the minimum value, n is equal to 21. Same thing if we had a negative. We're gonna say for maximum, n is equal to 21 or whatever. So all you do here for minimum, maximum value, so for which, that all they're saying here is for which x value is are we gonna have a maximum value in this equation? Okay, so here they're saying for minimum n is equal to 21. All you do is just take this, what's in the bracket, n minus 21, equate it to 0. You take it to the other side, you take 21 to the other side, n is equal to 21. So for minimum, n is equal to 21. That's all that they are saying here. Remember, the reason why they're saying minimum is because a here is positive. If a was negative, they're gonna say for maximum, n is equal to 21. I hope we're on the same page there. Therefore, T21 will have the lowest value. Consider the quadratic pattern 4, form 8, 16, and on and on. A, what is the difference between the 50th and 51st term? Okay, so on this one, obviously first things first, you have to get your general term. This one, what is the difference between the 50th and the 51st term? For a question like this, the first thing you want to do is calculate the first differences. These are the first differences right there. Now if you calculate the first differences, that means from here we will have a linear number pattern. Okay, so we calculate the difference between that and that, and we get a constant numbers there, constant differences here. So we're gonna continue and say b plus c is equal to 0. Remember, it's first term. Then b is equal to constant term 4. Now we're gonna say b plus c is equal to 0, b is equal to 4. Obviously we substitute b into b plus c, it becomes 4 plus c is equal to 0, then c is equal to negative 4. Therefore our general term is Tn is equal to 4n minus 4. Now note, for the first term of the linear pattern, okay, it gives t2 minus t1. We get t2 minus t1, t2 minus t1, right, of the quadratic pattern. Then for the second term, okay, of the linear pattern, we get 3. It gives t3 minus 21. That's for the second term, which is this one. Okay, so for the first term it was t2 minus t1. Remember what I said in the previous video. Okay, so for the first term of the linear pattern, remember I said this is the linear pattern there because of we calculated the first differences first. So listen, t2 minus t1 gives us the first term of the linear pattern, then t3 minus t2 gives us the second, right? This means we need to use the 50th term of the linear pattern to get t51 minus t50, okay? t51 minus t50, isn't it? I mean, think about it. t3 minus t2, right? It gives us the second term for this one. So now we want the difference between the 50th and 51st term. So obviously we need to use the 50th term of the linear pattern to get t51 minus t50. So therefore t50 is equal to 4 times 50 minus 4, which is equal to 196, and that is it. You're done. So guys, I need you to think about this very, very well, why I'm saying that we need to use the 50th term of the linear pattern. Remember, we said t2 minus t1 gives us the first term, right? The first term of the quadratic pattern. First, t2 minus t1 gives us first term of the linear pattern. So now we want the difference between t51 minus t50. Okay. of the quadratic pattern. Let me just say that so that you understand. It's of the quadratic pattern. So remember here, t2 minus t1 gives us first term, right? So obviously we need to use t50 of the linear pattern to get the difference between t51 minus t50, because if we're t50 somewhere here, right, and 51, we're gonna say t51 minus t50 gives us that difference there, which is the 50th term. Okay, because we're saying 51 minus 50, t51 minus 50, just like here, t21 minus t1 gives you 1 first, right? First difference. Same thing, t51 minus t50 gives you t50, right? I mean 50th term of the linear pattern. You see what's going on? Take your time to process this and make sure you understand what I'm saying here, and I'll see you in the next video.